So let's practice variation of parameters. So let's say I've got myself a little problem where I've got like y prime plus 2y is equal to x cubed times e to the negative 2x. Like, yay, my voice is getting squeaky. Okay, so my first option or strategy or whatever is to solve the homogeneous version. And so to do that, I'm going to say, well, let's pretend this is equal to 0. So y homogeneous prime plus 2y homogeneous is equal to 0. Now note that there's no y's on this side, so I can get away with it. If there had been y's on this side, then I've got all kinds of problems. The only way this works is if the stuff on the right has to be a function of x, okay? So I got this thingy is equal to that thingy, so that's d. Well, you know, I can do this. I know the answer. I don't know the answer. I mean, I know the little strategy. The strategy is that my homogeneous solution is some constant times e to the minus integral of the coefficient in front of the y. So look, I have to do less work. So I've got c e to the minus 2x, like that. Woohoo! Okay, so then I'm going to guess a solution of y is equal to u times this. Now I'm not going to use the constant because the constant can just get folded into the u. All right, and then I'm going to go y prime is equal to u prime e to the minus 2x plus u times negative 2 e to the minus 2x. Hey, screw over. 2. Okay. And then stuff involving plugging it into the original. So I'm going to plug this into the this. Okay, so like right here. So I've got u prime times e to the minus 2x minus 2 u e to the minus 2x, and then plus 2 times, and then this goes away, u. Then the y part is this part, which will go here, to u e to the minus 2x, and that has to equal x cubed times e to the minus 2x. And because I'm kind of genius, these two cancel out, and I end up with u prime e to the minus 2x is equal to x cubed e to the minus 2x. The e to the minus 2x is cancel out, or I could just say I multiply the whole thing times e to the plus 2x. But I got u prime is equal to that, and I'm all kinds of awesome. So I can say that u is equal to 1/4 x to the 4th plus c. And somewhere along the way, I got to remember why I was doing this, because I had this guess that y was equal to u times e to the negative 2x. Like that. So I'm going to plug that in because I'm kind of amazing. And I'm just going to leave it like that because I'm also kind of lazy. So I could do that. But anyway, so here's my answer. 1/4 x to the 4th plus c times e to the minus 2x. And that's my beautiful solution to that linear differential, non-homogeneous differential equation. Okay? Kind of getting it? Kind of getting it? Meh. Okay. So, sure, let's do this again. Meow. Okay, so one more, and this one you kind of try to do on your own, see how far you can get. So I'll write it out. So I've got y prime plus cotangent x, y equals, well, so like cotangent of x times y is equal to x cosecant of x. So you have something kind of like that. So you want to, you recognize that over here on the right is just a function of x, so that means I can solve it by setting it equal to the homogeneous part, and then working through it, guessing u to the homogeneous, u times the homogeneous, and solving for u, and being all happy and stuff. So pause the video, give that a shot.
Alright, so I'll just assume that you worked through that. Alright, and now, so remember that our solution is to find the homogeneous part. So we do y homogeneous prime plus cotangent of x times y homogeneous is equal to 0. Now at this point you might be like, okay, cool, so that gives me that y homogeneous is equal to constant times e to the negative integral of the cotangent of x dx, but I don't remember what the cotangent was, and at some point you said we should be able to do all this without a calculator, so what's up with that? And I'll be like, okay, so check it out. Well, I might not remember the inverse of cotangent, but I do know that cotangent is defined as cosine over sine, because I'm smart and stuff, and I can trig like nobody's business. All right, so since I'm given that, then my next step can be to, let's do some u substitution. So I'm going to let, I don't want to use u because I'm going to use u later, but I'll say v. I'll do v substitution. Let v equal the sine of x, and then dv is equal to the cosine of x. So that means that I can rewrite the integral of cotangent as the integral of 1 over v dv, like that, because that's kind of awesome. So that's v to the negative 1 dv. So that's the same thing as negative 2 v to the negative 2. Wait, no, I add 1. Wait, hold on. I'm not stupid. I can do this. How about, because I've been doing this like all day, and I'm not thinking about it because I'm playing with my audio to try to get a better recording. So I'm thinking about audio instead of math. So natural log of v. Okay, so that means that that's the natural log of sine of x, which is kind of cool. All right, so I know that the y homogeneous is equal to c times e to the negative natural log of sine of x, which is actually kind of cool because I can simplify that. Because I've got c times e to the natural log of sine to the negative 1, like that. Okay, cool, got it, sine to the negative 1. And the e to the natural log thing is just sine x to the negative 1, because, right, it's e to the natural log, they're just like inverse functions of each other. So that's just c times 1 over sine of x. So there's my homogeneous solution. Fantastic. See, I can do math. All right, so now I'm going to guess. This would be fun.
And my guess is going to be y is equal to some unknown u times 1 over the sine of x. And I'm just going to make my life easier and write this as u sine x to the negative 1. Otherwise, I'm going to have to do like a quotient rule, and I can never remember the quotient rule, so I just always do the product rule. So y prime is equal to u prime times 1 over sine x plus u times the derivative of that thingy. So that's negative 1 sine x to the negative 2 times the derivative of the thingy on the inside, which is cosine of x. All right, so remember we were talking about like Cal 2 and stuff, and it's like, if you can't do Cal 2, you can't do diffie-q, and you're like, but, and I'm like, no, seriously, you can't. Okay, so this is what I meant. So this is cosine x like this, with a sine squared x down here, like that. Do. And I don't really feel like simplifying it that much, so I'm just going to go ahead and plug it in. So this is going to be plugged in here, it's going to look like this, and I've got u prime over sine of x minus u cosine of x over sine squared of x, and then plus cotangent x times y, and y is this thing. So y is u over the sine of x, and that's supposed to equal x times the cosecant of x. Yay! Math. Okay, so that's kind of cool because I've got u prime times sine x, and that's minus u. Cosine over sine is cotangent, and then I have an extra sign on the bottom. Then I've got u cotangent x. I'm just doing this basically to prove that that little term cancels out. X cosecant x, like that. Alright, and cosecant of x is just 1 over sine x. I'm just going to write it like that to be obvious in a second, if you haven't already gotten there. These two go away. I've got u prime over sine of x is equal to x over sine of x. The sine of x clearly goes away. So I've got u prime of x is equal to x, or u prime of x, you know what I mean. So if I integrate both sides, I get 1/2 x squared. Alright, now my original guess, remember, was that y was equal to u times 1 over the sine of x. So that means that u is equal to 1/2 x squared over sine of x. Oh, plus c. Sorry, plus c. Plus c right there. 1/2 x squared plus c, there we go, times 1 over the sine of x, like that. All right, so now you should have had plenty of practice with variation of parameters, which will help you whenever you get into doing variation and separable and all kinds of stuff on top of that. So this will be fun.